Hello, class. Mr. Lee here. All right, so today's video, I'm going to show one proof of the Pythagorean theorem. Okay, there are many proofs out there. This is just one of my favorites. Okay, so as you see here, we have two big squares. Okay, so I'm looking at this big square as well as this big square. Okay, so we're going to assume that they're the same square. Okay, I'm not tricking you. And what you see are four triangles kind of rearranged a little bit differently in both. Okay, so in the first one, I have it in each of the corners. And if you can kind of imagine, right, if I take, let's take this triangle, I'm actually just keeping it in the same place. Okay, bottom left. This triangle, I moved over to here. Okay, and then this triangle, I moved down here. And then this triangle, I shifted over here. Okay, so you'll see why I did that in a second. But you just have to know that I took these four triangles, rearranged them in the bigger square to make it look like this. Okay, so let me go ahead and clear that. And then we're going to add some labels here. Okay, so you should have seen in your Canvas page already, right, the labels of a right triangle. We have sides A, B, and C, right? So assuming these are all the same right triangle, and they are, this would be, I can label this as A, this would be B, which then means this is A, this is B, right? They're just kind of rotated a little bit. This is going to be A, this is going to be B, this is going to be A, this is going to be B. Okay, so I promise you I'm not tricking you. I made all of the lengths the same. I programmed it that way. So all this should be true. Okay, so if this is A and this is B, that means this is also C, right? That's the hypotenuse, longest side of the right triangle. That's going to be C. That's going to be C. That's going to be C. Okay. So what we're going to do now is talk about the area of this white space, right? So I have four triangles in the bigger square, but then I have this smaller square, which is all in white. And if you know the area of a square, it's just going to be the two sides multiplied by each other, right? So any rectangle is going to be length times width. So same thing here. It's going to be C times C, or in other words, C squared, right? So again, if I'm talking about the area, I'll put this in red. This is going to be an area of C squared, okay? So area is in red. All right, so now let's shift over to this right side where I rearrange the triangles, and let's do some labeling again. Okay, so remember, I took these four triangles and just rearranged them. So we should have similar lengths. This is going to be A, that's going to be B. Over here is going to be B, and over here is going to be A. Okay, so if you kind of do some logical reasoning here, this leftover side should also be A and A. Okay, and this should be B and B. Some other ways to prove it, just real quick, if you know that this is A and I kind of relate it to this side, this should also be A, which then in turn would prove that this is also A, right? So you can kind of use that reasoning to kind of visualize the rest of it if you can't see it. But we should know that we can label all these sides as such, okay? So that gets us to the white spaces now. So check this out, right? I have a smaller square here now, which is going to be A times A, right? So this area is going to be A squared, okay? This square on the bottom right, I have a length of B times length B, so this is going to be B squared, okay? So follow this logic now. We're finally hitting this home. Follow this logic, right? We had this empty space in white, which is C squared, and now we have two empty spaces, both in white, that are A squared plus B squared. Okay, so we talked about in the beginning that I took these four right triangles and all I did was rearrange it in the bigger square to make it look like this. Okay, so if I started here, the empty space, no matter how I rearrange the green right triangles, right, no matter how I rearrange it, as long as they're still in the bigger square, whatever leftover white space I have should be equal. Right? So let me say that again. I have an empty space right here. And no matter how I rearrange the green right triangles, right, the rest of the white space, the leftover, should still be the same area. So that's how you get this whole C squared is equal to A squared plus a B squared. Okay, so that's just one proof of the Pythagorean theorem.